You can't spell wireless without wire. So we were doing some calls before the conference, and I was talking to Frenay and Keith. They were talking about, we want to build some cabling and we want to show some of the problems. And I started talking about it, and originally it turned out I was just going to be advising them on how to do some of this. They said, you know what, maybe you should just go ahead and do the presentation. So I ended up doing it. My name's Mike Pennacchi. I own a company called Network Protocol Specialists. I am a networking geek. I love networking. And these days, I've been playing around a lot with cabling. So I just thought I'd put a few things up here as far as distance limitations go, frequencies, things like that. We're not going to spend a lot of time digging into this, but some of the important things here, and I keep hearing things in these last few presentations about multi-gig, about connections, about all that, which makes me really happy because those are the things I want to talk about. And what we see is with Cat5e right here, Cat5e is capable of doing 2.5 gigabits per second up to 100 meters. Now, all of these are capable of doing Class 8 PoE up to 100 meters. So what we need to think about when it comes to Cat5e and Cat6 is what data rate do I need to run and how far do I need to run that? Now, toward the end, we're going to get to how can I test this to see if these things are really going to run across these cables. Another one, and I see this more and more, are thin patch cords, 28 gauge patch cords. Now, it is really important to remember that anytime we use 28 gauge patch cords, these derate the link. So even if we're sticking with 6 meters of patch cord, 3 meters on each end, that takes our link down to 96 meters. And if we have longer thin patch cords than that, then we need to derate that by a factor of 1.95. So there's just a quick little calculation in there. So when we build these things out, we always have to assume that we're working with a maximum link length. And so unless we're measuring the length, designing our patch cords exactly for that, we need to take that into consideration. Temperature impacts cable length. So this is 295 feet of Cat6 that I stuck in my oven. Now, my wife heard me beeping away on the oven, and she said, "What are you cooking?" Because she knows I don't cook. And I said, "Cat6." And she said, "Okay." Because she's used to me doing things like that. Now, the one rule is I can't stink up the house. Can't heat it up that much. But what I did was I heated this up to 135 degrees, because that's about where I could get it and it wasn't starting to smell. And I put a cable tester on there. What we see is it failed insertion loss. Whenever they go in and test this cable and rate the cable, say you can go 90 meters of the permanent link and have 10 meters of patch cord on there, they do that at 68 degrees. So if you're working in an environment, say outdoor, where you could have temperatures higher than that, what you're going to find is that the maximum lengths for the cable. Did we lose a video? No, I still have it on the computer. There we go. It just needed to be rebooted. It's too hot. So that changes the length. Poor connections are worse than bad cable. So what we find is, these are just some pictures that I've taken. The screw terminals are connectors they sell at Home Depot that say they are Cat5, Cat5e compatible. Well, I don't know what's going on there. So in this case, I tested those and it did pass 2.5 gigabits per second. The other ones, we see they did not take advantage of the strain relief on there. Now, where does that become a problem? And I want to talk about PoE for a second, because the other thing that I hear more and more is 802.3 BT. As the Are you going to? I'll try it. As the bandwidth requirements increase for the APs, let's see. As the bandwidth requirements increase, so do the power. So this is how we send power over Ethernet. We've got transformers on each side. We center tap those transformers and we inject the power in there. So one pair is positive, one pair is negative. Now the big problem comes in when we have more current flowing over one conductor of that pair than the other. So when we don't have proper strain relief and proper connections, what happens is we end up with a resistance imbalance. And that resistance imbalance causes more current to flow over one of the conductors. Big deal? Yes. Because now more current's flowing through one side of that transformer than the other, and that causes a saturation of the transformer and it causes data loss. So we can see a link that was working just fine when we had low current or no PoE on there, and when we start running PoE across it, all of a sudden that link isn't working properly anymore. So it's important that we take a look at things like resistance imbalance on these links, and are they within balance of each other? Another one, because I hear people, what cable should I use? Well, guess what? Sometimes Cat5e is good enough. Now, in the evening event, I talked about what's one of the big differences between Cat5e and Cat6. One of the big differences is that Cat6 typically has a center spline, makes it harder to bend. So if I've got an application where I need to make sure that I can feed that wire in there, Cat5e might work. Do I need 2.5 gigabits per second? Cat5e might work. Wire mappers don't tell the whole story. I did this as a short little webcast with a friend of mine that's a managed service provider, and he said, yeah, I'm having some cable installed. And I said, how are you having that cable tested? And he said, oh, they use this little deal. It shows them if all the pairs are good. Well, that doesn't tell us really what's going on. This is not good enough. We need to be testing that cable when it's installed to make sure that it meets the requirements of what we need so that when we go turn on those APs, they're not flapping off and on and off and on because they don't have enough power. Not all existing cable needs to be replaced. So it's important that if we have a tool, a way to go in and measure what the existing cabling can do, we can ensure it's going to meet our requirements. So it's weighing that cost. Do I need to replace this cable, or can I test this cable over a period of time and make sure that that cable that I'm going to use to deploy these is going to work for me? Now, it turns out, we proved the other night, you can get 5G base T out of bananas. So this is a picture, and you can watch the video. We recorded the whole thing. We took 4 of the conductors, and we made sure to use pairs 1, 2, and 3, 6, because we figured if all else fails, we could get 10 meg out of it, right? So we stripped them, we stuck them in there, we plugged them into the bananas, and we ran the traffic through, and to our surprise, we were able to get 5G base T with 0 errors out of those bananas. Now, as Keith mentioned, when I get back, I'm going to go buy some more bananas, and we're going to test all 4 pairs. We're going to run it through there. And you say, but Mike, you can't get PoE through bananas. We could. Now, you're going to be able to run something like a transistor radio, because we could only get about 9 volts. But we did get power through the bananas as well. So what I'd like to finish up with is asking you to not use the S word. And the S word is should. I hear this so often in our industry. That should work, that should do it, that should fix it. And what I like in coming to this is my first year at WLPC. What I like about this is the attention to measurement And I don't know if in many other industries in IT I see that attention to measurement, but it is important we measure and we be definitive. We say this will work, this has been fixed. All right, I figured you put me at the end so I could just keep going. But I want to thank you for having me out here and listening to me, and I hope that what I talked about was somewhat informative. And watch the video of the evening event. We had a lot of fun. Thank you.